Hello grade 10, Mr. G here, and we're going to continue doing some questions preparing you for the upcoming examination. This time we are going to do a question on longitudinal wave. This is also a question taken from November 2013, right? This was question 3 from November 2013 at the Northern Cape province. Now this question said the following. It has some fixing. I changed the picture. It was also a lion, but this is a picture that I take in one of my trips. The picture on the side shows a roaring lion. The roar of a lion is a loud, low sound. Now, what type of wave? A sound wave. 1.2. What wave properties are associated with loudness and pitch of sound? Explain each of them. 1.3. Write down the following substance in ascending order with respect to how well sound travels through it. So, and the materials we are talking about, the mediums we are talking are water, warm air, metal, and cold air. And 1.4, write down two medical applications of ultrasound. For 2 marks, the total is 13 marks. So we are going to start now with the solutions. Now, let's say what type of wave we have here. Now, according to the way in which particles move with respect to the propagation of the wave, they can be classified as transverse. In the previous video, we talked about transverse wave, or longitudinal wave. So let's quickly separate them before we answer the question. Okay, so wave, we're going to classify wave in terms of the motion of the particles versus the motion of the wave. Motion of the wave. Now, if we do that, we have two types of wave. We have the transverse wave that we spoke about it yesterday in the previous video, and we have longitudinal wave. We have the longitudinal wave. All right. Now, in the transverse wave, as we mentioned before, this is very fast. The particles will move perpendicular to the propagation of the wave. In the previous video, please, you can go and watch the first video. You will see exactly how this happened. Particles move up and down, for example, while the wave is propagating to the front. So I'm just going to write the direction of the particle versus the wave direction of particles move perpendicular to the propagation of the wave. And yesterday we saw an example here in which we saw a wave. This wave will have some particles. I am not going to draw many particles. These particles will move up and down in the wave, but the wave itself is moving in one direction which is perpendicular to that of the particles. Okay, so that is a transverse wave. Now, in a longitudinal wave, this is not exactly like this. What happened is that the particles will move parallel to the propagation of the wave. Here, the particles will move parallel to the propagation of the wave. Now, this type of motion where the particles move parallel to the direction of propagation of the wave will happen, for example, in a spring. If you have a spring and you disturb the spring, the pulses that are produced, or the wave, if there is a trend of pulses, will move parallel to the propagation of the wave. For instance, in this case here of the spring, the wave is going to propagate in that direction. Now, the particles will move in one direction and in another direction. So move forth and back all the time. Particles move forward and back all the time. This is what we call longitudinal wave. Another example of longitudinal wave is sound, which is the case of the question. Sound is a longitudinal wave. Why? Because the particles move parallel to the propagation of the wave. So that is the answer for 1.1. Sound. What type of wave is sound? Sound is a longitudinal wave. So let's go to the next question. 1.2. What wave properties are associated with loudness and pitch of sound? Now, loudness. Loudness is going to be in sound. Now, this is about sound, not about just longitudinal wave, but only about sound as a longitudinal wave. Loudness is related to amplitude. Loudness is related to amplitude. That means that the higher or the bigger the amplitude, the louder the sound is going to be. The higher or bigger the amplitude, the louder the sound will be, and the other way around. The smaller the amplitude, the softer the sound will be. So, the question is, what physical quantity is related to loudness? That will be amplitude. Explain that. The higher the amplitude, the louder the sound. The lower the amplitude, the smaller the amplitude, the softer the sound will be. So, amplitude have to be with volume, in other words. Alright, with the volume of the sound. Let's go to pitch. Now, pitch is going to be related to frequency. So pitch is what we refrain sound as a frequency, or frequency is what we refrain sound as a pitch. That is the way of saying this. So pitch is related to frequency, and we need to know that the lower the frequency, the lower the pitch. So the higher the frequency, the higher the pitch. This is related to these difficult physical quantities. Now, question 1.3. Write down the following substances in ascending order with respect to how well sound travels through it. So let's quickly look at the factors that affect the speed of sound. Okay? So let's look at the factors that affect the speed of sound. Okay? Now, the first factor that is going to affect the speed of sound is going to be the state of matter, either solid, liquid, or gas. And in order of moving faster, the matter will move faster in solid than liquid than gas. So this is the order: faster in solid, following by liquid, and then the gas. So the same substance will move faster when it's in state solid than when the same substance or that substance is in a state liquid, and that substance that when it's in a state gas or in the gas state. That happens because of the distance between the particles of the substance. Okay. Now the second factor is going to be temperature. It's going to be temperature. It's going to be a temperature. Now, the temperature, the hotter the medium it is, the faster the particles will move. So, for instance, the speed of sound, which is a longitudinal wave, will move faster in warm temperatures or hot temperature than cold temperatures. Alright? So temperature is the second factor that affects the speed of sound. Speed of sound move faster in temperatures that are hot than in temperatures that are cold. The higher the temperature, the faster the sound will propagate. And the third factor is going to be pressure. That is the other factor we're going to look at. The other factor is pressure. The higher the pressure, the faster the medium, the sound will propagate. Okay, so that is the other factor that affects the speed of sound. Now, in the question, we have different substances here. Now, these are the materials or mediums they give us for sound to travel. We have water, we have warm air, we have metal, we have cold air. So we have to look at what factors are there. The first of all, we're looking for metal. So metal is the fastest one, which is this one here. It's in solid state and it's metal. The particles are very, very close to each other, so sound will propagate faster. Now we have air, warm and cold, and we have water. If we go to the state of matter, here we can see that the liquid is the second fastest one. So this water will be the second faster medium in which sound will propagate. Now we have air. This is air and this is air. So the factor that is changing here is the temperature now of the air. It will move faster in warm than in cold. So this one here will be the third faster medium and this one will be the fourth faster medium. This is in order of ascending speed of sound. So they say there here, they say in order with respect to how well sounds travel through it. So the one that is moving the fastest one is a metal, followed by water, then warm, then is warm air, then is cold air. Okay, now that is from faster to slower. If you the other way around, from slower to faster, then you're starting with a cold air, then is warm air, then is water, then is metal. So you have to look at the question, what do they want? Okay, they want from slower to faster. Okay, so this is the question, the answer for this specific question. And then the final question is an application in terms of ultrasound. Write down 2 medical applications of ultrasound. Now remember, ultrasounds are sound waves which have the frequency greater than 20,000 Hz. Remember, we cannot hear sounds with that frequency. And this one is not in terms of loudness, not how loud, it's in terms of frequency. So ultrasounds are sound waves which have frequencies that are greater than 20,000 Hz. We cannot hear sounds with that frequency. And remember, we're talking about frequency, not loudness. So it doesn't mean that the sound is very loud. It could be very soft, but the frequency is very high. So we cannot hear, humans cannot hear that frequency. Now, where are we using ultrasounds in medicine? I'm going to list a couple of examples. Some examples are to monitor the development of babies in the mother's wombs, in physiotherapy and cancer treatment, evaluation of blood flow in blood vessels. Now, there is more application. I'm not going to write all of them, but there is many other applications that you can look, you can do the search. So this is the question that we were looking at is in terms of longitudinal wave, mostly sound wave, and it could be in the upcoming exam. So thank you very much for watching. Good luck with exams, and I'll see you in next video. By the way, this picture here is a picture I took in the nearby place of lions near Kimberley, of this little lion here. It was just eating. Okay, thanks a lot for watching. Up until next time.